Hi, and good afternoon. So I am walking through a handful of standard normal distribution questions that you might find on your homework. Hopefully my tablet pen will cooperate with me today as we look through some of these examples. And so I have my calculator here. And as always, when we have a normal distribution, we want to draw this sketch of a normal curve. Oh, there we go. Something like that. Right, and so our mean here, because it's a standard normal, this word tells us it's standard. That means our mean is 0, and our standard deviation is 1. And so your calculator might default to that. I have an older TI-83, so you may have a different setup than I do, but if you have a newer model, you want to make sure the mean is defaulted to 0 and 1. Okay, so our first question here is find the probability that z is less than 1.38. So we're going to put, let's see if I can find my pen again. We're going to put a line right here at 1.38. Sometimes my tablet pen does not like to make curves. Try it again, 3. 8. Sometimes if I do it really fast, I can trick it. And we're looking for the area under the curve less than 1.38. So what we're going to do is we pull up our calculator and we're going to go to second vars, which is our distribution menu. And we want normal CDF, which is 2. And in those parentheses, I'm going to put the lower bound. Well, our lower bound here, this actually goes out to negative infinity. It doesn't like to do infinity either. There we go. If I do it really fast, sometimes it will cooperate. All right. And so our calculator doesn't know what negative infinity is. So we have to kind of tell it something else. I'm going to do a negative down here, 1, and then this second comma, which is this little 2 e's right here. 1e to the 99, and that's what our calculator will think is negative infinity, and then our upper bound is 1.38. And so my area there is 0.9162. It says to round to 4 decimal places. 0.9162. Our next problem is the same type of problem for a standard normal distribution. Find the probability that this z is between negative 1.26 and positive 1.5. So we want all this shaded area here. So now we don't have to worry about infinities. We can just use those straight endpoints. Again, I'll do second vars down to normal CDF. And I'm going to tell it negative 1.26, comma, and my upper endpoint is 1.5. And I get 0.82935. So I would round that up to 0.8294. I can get my pen to cooperate. Where did it go? All right, let's try this. 0. I don't know what happened there. Hold on, let me see. Let's do this. Check my pen. There we go. And I have, let's see. Oh, there it is. Okay, 0.8294. We say, does that make sense to us? Well, that's 1.26 standard deviations below and 1.5 standard deviations above, and 83% living in that area sounds about right, because the entire area under our curve should be 1. All right, the next question is a little bit different. We have, for a standard normal distribution, find z greater than c equal to 0.2966. So in this case, again, I'll draw my picture. But now we're looking for something different. So we have our mean here at 0. We want some c, some constant here, so that this area above is equal to 0.2966. And so for this type of problem, we're going to use a different function on our calculator. We're going to use the inverse norm. So if this C cuts off 0.2966 above, then the remainder here in this area would be 1 minus 0.2966. So that's the first thing I'm going to calculate. I will say 1 minus, I want to correct minus, not a subtraction, 0.2966. And I get 0.7034. So put that here. You're probably saying, why are you looking for the area below when we're given the area above? So we're interested in this area, but our calculator, when we use the inverse norm function, it needs the area below. And so we have to, if we're given the area above, we have to take 1 minus that first. And so I'm going to go to second bars again, scroll down to inverse norm this time. This time we have the area, and we're looking for the cutoff point. And so here, all I have to enter is 0.7034. Just give it, if you have a newer calculator, it might ask you the area there for area under the curve. And I get 0.5342. And this one asks for, let's see, how many decimal places? 2 decimal places. So that would just be 0.53. So our C here is equal to 0.5, I think that was 3. So curvy 3 here. All right, so sometimes, let's see, I can get my pen to cooperate. There we go. 0.53 would be our solution there. All right, I think I have a few more from this section. Now that I got my pen to work, my cursor is not cooperating. Here we go. All right, let's do this. Let's arrow down. There we go. Okay, so this next question. Assume the readings at freezing on a bundle of thermometers are normally distributed with a mean of 0, standard deviation of 1. So automatically we know that this is a standard normal distribution. And so we have the same situation as before. It's just written in a big sentence. And so I'm going to draw my picture as always. And I have a 0, standard deviation of 1, and we want the probability that our reading is greater than, oh, there we go, greater than 1.78. So this is just like one of the earlier problems we did, only we want normal CDF. So I'm going to clear this out and say second bars, go down to normal CDF, that's number 2. And our lower endpoint this time is 1.78. And our upper endpoint this time will be actual infinity, not negative. So I will say 1 second comma, which is double E 99. Our calculator will think that means infinity. And I get 0.375 or 0.0375. So I will put 0.0375 is this area here. And that's our solution. All right, the next question is a between question. So we know we're going to shade the middle section on this one. So I'll draw my picture as always. Here's my 0. I'm looking between negative 1.378 and positive 1.378. And it's saying, what's the area under the curve between these two values? I will say, clear that out. Again, normal CDF. And my endpoints here will be negative 1.378. And a comma, and my upper endpoint is 1.378. That will give me my area in between. So I end up with 0.83179. I'll round that up to 0.8318. 0.8318 is the area in that shaded region. Okay, and this is the last one that I have here. And this one is similar to that one. Let's see if I can get it all on the screen here. And now we're looking for about what percent of the area under the curve of the standard normal distribution is outside of that interval. So we're going to go through the same process. And this is negative 2.42. And this is positive 2.42. But now we're looking for what's outside. So if you remember from our probability section, if we're looking for the outside here, we could simply, I can make this go away, I'm not sure what that was. We can simply find the area in the middle, and we know the area under the entire curve is 1. So what we'll do is we'll find the area between, just like we did on this last problem, and we'll say normal CDF. And this time we're looking at what, negative 2.42, negative 2.42, comma, 2.42. And so that gives me the middle region. That's 0.9844, right? I'm going to round that. Actually, yeah, I'll round it to maybe 6 decimal places just to be extra safe. So what's here was 0.98, what was it, 4479. Okay. Let's just 4479. Okay, that means what's on the outside of here is 1 minus that. So I will take 1 minus 0.984479, and that should be the area in those leftover shaded regions. I will say 1 minus 0.984479, and that gives me 0.015521. So this probably wants 4 decimal places. I would say 0.0155. So on the outside, 0.0155. And so if we think about that, does that make sense? Well, by our empirical rule, we know that 2 standard deviations out should leave 5%, 5% on the outside here, which would be 2.5% on either side. And this is a little bit further. This is almost 2.5 standard deviations in either direction. So that should be a really small area that's left over on the outside. So hopefully running through some of these standard normal questions will be helpful for you. And we will meet again at a later date to look at applications of the normal distribution. Thanks, and have a great day.